Hello, today we're going to be talking about adding and subtracting polynomials. But before I do that, I want to recall how to add or subtract fractions. So far we have just addition, but the same idea can be applied for subtraction when you add the negative. Now we have these two properties. The second property is a brute force method to adding two fractions. We'll see later that we don't necessarily need to use this method every time, but it does work every time. Okay, so one of the other things that we want to consider when we are talking about fractions, and especially when I have a generalized formula for it, is we want to make sure that the denominators are never zero. We don't have these problems in these cases, but in general, we do not want the denominators to be zero. So we'll see here that we want x values other than -2 and x values other than -2 and -3, but we'll talk about that when we get there. So here we see in our first example is the sum of 1/3 plus 5/3. Now, casting aside the physical idea of what's happening here, we're just going to apply the arithmetic approach to this. We see that they are common denominators, so this can be written as 1 plus 5 over 3. And so now we just add across the numerator, leaving the denominator alone. And so then we get 6 over 3. And this can be reduced because 6 divided by 3 is 2. And so we get the sum of 1/3 plus 5/3 is 2. Again, we're going to disregard the physical idea of what's happening. We're just going to look at the arithmetic idea of what's happening here. Okay, so next we have 2/3 plus 1/5. Now we are going to look at the second idea here where they do not share a common denominator. So we're going to write this as 5 times 2 plus 3 times 1 all over 5 times 3. And so then this becomes 10 plus 3 over 15, which finally becomes 13 over 15. And so the sum of 2/3 plus 1/5 is 13 over 15. Next, we have this one here. Now, I'm going to do two methods to this one. I'm going to use what I call the brute force method, which is going to be 1 times 3 plus 6 times 2 over 6 times 3. And that's going to give me 3 plus 12 over 18. And so then I finally get 15 over 18. And so that will reduce. So we can divide the top and bottom by 3. And we get 5 over 6. Okay. Now, the other method I can look at is I can get a common denominator with 2 and 3 by just multiplying the top and bottom by 2. So let's look at 1/6 plus 2/3. We're going to rewrite it. And what I'm going to do is I'm going to multiply the 2/3 by 2 to the top and bottom. And I get 1/6 plus 4 over 6. Again, if I were to reduce 4 over 6, I would get 2/3. But I don't want to do that because I want to keep it in two terms being common denominators. And so then, using the first property we have here, we get 1 plus 4 over 6, which equals 5 over 6. And we get the same answer between the two methods. Again, what you can notice here is there was an extra step. There was a consequence to using the brute force method. Usually you'll have to reduce at the end of the operation, but you do not need to find a common denominator. Similarly, for this one, it may not be obvious what the common denominator is, so we can use the brute force method. So that's going to be 6 times 1 plus 4 times 5 divided by 20. Let's do 4 times 6. I'll do the multiplication next. So that's going to be 6 plus 20 over 24. So that's going to be 26 divided by 24. Divided by 2 to the top and bottom, we get what? 13 over 12. Now, another method that we could do is we can look at common denominators. So looking at the 1/4 plus 1/5/6, we see that the common denominator could be 12. So I'm going to multiply the top and bottom of the first one by 3. And I'll multiply the top and bottom of the second one by 2. And I get 3 over 12 plus 10 over 12, which equals 3 plus 10 over 12, using the first property we identified, which then becomes 13 over 12, which is the same answer as we got in the previous case. Okay, so we want to use these ideas of adding real numbers, and we want to use that idea for adding two polynomials. So for the first example here, we see that they share a common denominator. So that is, we're just going to add across. So adding across, we get x plus 2 divided by, and just like in the other cases, we are going to leave the denominator alone. So that's going to be x plus 2. And we could identify this as being 1 because we have the same over the same. But one thing that we want to keep in mind is this equals 1 when x does not equal 2, because an x equals 2 is not in the domain of this sum. Because if we have x equals 2 in either one of these cases, we would be dividing by 0, which is not allowed. Okay, the next one we have here is a method. We're going to have to use the second idea here, where we have no common denominator. So this is going to be written as 2x squared times x plus 3 over, minus 5 times x plus 2. And this is all going to be over x plus 2 times x plus 3. So we are going to distribute in the first two cases on top, and we are going to FOIL or use the distributive property for the denominator. So let's expand all of this out. So we get 2x cubed plus 6x squared minus 5x minus 10 all over, that's going to be x squared plus 3x plus 2x plus 6. Okay, do we have any like terms on top? The answer is no. And we have some like terms on bottom. So to finish this off, we get 2x cubed plus 6x squared minus 5x minus 10 all over x squared plus 5x plus 6. And so that would be the addition of these two polynomials.